Hello students, welcome to the class. Next question is conversion of 1 megawatt power on a new system having basic units of mass, length and time as 10 kg, 1 dm and 1 minute respectively. So here mass is given as 10 kg and length is given as 1 dm and time is 1 minute. So we need to convert 1 megawatt power. How to do this? So according to the formula, that is N2 is equal to, we have power is equal to, the dimensional formula is m L raised to 2 T raised to minus 3. Then the formula is, it is N2 is equal to N1 into bracket M1 divided by M2 to the power of 1 and L1 divided by L2 to the power of 2. And then next T1 divided by T2 to the power of minus 3. Okay, so now we can substitute M1, L1, T1 and M2, L2, T2 values. So that is equal to, so N2 they have given 1 megawatt, therefore it is 1 into 10 to the power of 6 into bracket, it is 1 kg divided by 10 kg to the power of 1, and here it is 1 meter divided by 1 dm to the power of 2, and here it is 1 second divided by 1 minute to the power of minus 3. So N1 is equal to, here it is N2 is equal to, this is 10 to the power of 3 and here it is 1 kg divided by 10 kg to the power of 1, and here it becomes 10 dm divided by 1 dm to the power of 2, and here it is 1 second divided by 60 seconds, as 1 minute is equal to 60 seconds to the power of 3. So if I simplify this bracket term and multiply it with 10 to the power of 6, we will get it as 8.16 into 10 raised to 12 units. 8.6 into 10 raised to 12 unit. That is option A is the correct option here. Option A is the correct option. So in this slide, we are solving many numericals on the dimensional formula and by using the conversion formula, that is N2 is equal to N1 into bracket, the relation between the two system formula. Okay, so by using that we are calculating. In this question, the correct option is option A is the right option. Okay, let us see the next question. In two systems of relations have among velocity, acceleration and force are respectively v square is equal to alpha square by beta v1, comma a2 is equal to alpha beta a1 and f2 is equal to f1 divided by alpha beta. If alpha and beta are constants, then relations among mass, length and time in two systems are. So here we need to calculate the relation, that is so given equation is, here it should be v2, it is not v square, this should be v2. Okay. V2 is equal to V1 into alpha square divided by beta. That implies V2 is nothing but L2 t raised to minus 1 is equal to L1 t1 raised to minus 1. And here it is alpha square divided by beta. So this is your equation 1. This is your equation 1. That is now A2 is equal to A1 alpha beta. So here it is L2 T2 raised to minus 2 this is equal to L1 T1 raised to minus 2, and this is alpha beta. This is our equation 2. This is our equation 2. Okay. Then from the second formula, that is F2 is equal to, here they have given one more formula, that is F2 is equal to F1 divided by alpha beta, that is M2 L2 T2 raised to minus 2 is equal to M1 L1 T1 raised to minus 2 divided by alpha beta. So dividing equation 3, so this you can take it as equation 3. So if I divide equation 3 by equation 2, if I divide equation 3 by equation 2, I will get it as M2 is equal to M1 divided by alpha beta, and here it is alpha beta, that is equal to M1 divided by alpha square beta square. It is alpha square and beta square. So squaring equation 1 and dividing equation 2 we will get. So what we need to do is, that is we need to square equation 1 and divide by 2. What we will get? We will get it as L2 is equal to L1 L cube divided by, sorry, alpha cube divided by beta cube. So dividing equation 1 by equation 2. So finally, if we divide equation 1 by equation 2, we will get it as T2 is equal to T1 into alpha divided by beta square. So in the question we can see now, that is what we got, M2 is equal to, we have M2 is equal to M by alpha square beta square. Okay, M2 is equal to M1 divided by alpha square beta square, and L2 is equal to L1 alpha cube by beta cube, and this T2 is equal to T1 alpha divided by beta square. So we can use the given equation. So what we did here, we have taken both the equation, that is V2 is equal to V1 alpha square beta. Here the dimensional formula of the V1 V2 it is written. Then it is taken as second equation. Second equation what they have given, that is A2 is equal to A1 alpha beta. So write A alpha beta as it is, where A is acceleration. So write the dimensional formula for acceleration. Then you will get equation 2. Then next, third equation what they have given, that is F2 is equal to F1 divided by alpha beta. So it is force. Write the dimensional formula for force. Then write alpha beta as it is. Then next, dividing 3 by 2 if you do, you will get M2. Squaring and dividing 1 by 2 if you do, you will get L2. Then dividing 1 by 2, you will get equation 3, that is for time. Okay. So here the correct option is option B is the correct option. So method is important here. Okay. So option B is the right option. Let us see the next question. The present units of length, time, and mass are changed to 100 meter, 100 second, and 1 by 10 kg. Then, so the options are, that is, the new unit of velocity is increases 10 times, the new unit of force is decreased 1 by 1000 times. The new unit of energy is increased 10 times. The new unit of pressure is increased 1000 times. So let us see how to do this one. The present unit of length, time and mass are changed to. So whatever the present unit is there, its value is changed to the mass is by 10 m, 100 m, time is by 100 second, mass is by 1 by 10 kg and length is by 100 meter. So how to do this one? That is, we know that unit of velocity. Okay. So here the unit of velocity is what? That is, velocity is equal to, it is meter per second. Velocity is equal to meter per second. According to option A, I am trying. Okay. So here we need to verify with all the options. That is, it is meter per second. In the new unit, it is 100 meter divided by time is 100 second. So if you see, you will get it as meter per second. Right? Means you are getting the same option. So option A is right. Next, unit of force. Next option, what they have given, the means we will try with everything. See option here, what it is given, the new unit of velocity increases by 10 times. It is not true. Why? Because the new unit is remaining same here. The new unit is being same after substituting the change in the value of mass, length and time. Okay. So next, force. Force is given by what? Kg meter per second square. This is force. So here the mass is changes to 1 by 10 kg into then length by 100 meter divided by per second. So time by 100 seconds. So it is time square. It is therefore 100 into 100. So this 100 will get cancelled. Then you will get it as 1 divided by 10 into 100. So 10 into 100 is how much? It is 1000. Therefore it is nothing but what? 1 divided by 1000. So this is the new unit which is not same as the given unit. Therefore, see, the new unit force decreased by 1 upon 1000 times. So this seems to be correct. This seems to be correct. Just we will verify with other options also. The unit of energy is increased by 10 times. See, the unit of energy is joule, but joule can also be written as kg meter square per second square. This is equal to, so mass is 1 by 10 kg into meter is 100 into 100 divided by time is, it is again 100 into 100. It is 100 into 100. So here 100 will get cancelled. It is becoming 1 by 10. But here they have given 10 times. If it is 1 by 10, then it would be correct, but it is given as 10 times. Therefore, this also goes wrong. Then next one, the new unit of pressure. So pressure is, it is Pascal. So Pascal is also written as what? Newton meter. So Newton meter is written as kg per meter per second square. Okay. So now, so in new system, kg is 1 by 10, then length is 1 by 100 and time is 1 divided by 100 into 100. Okay. So if I simplify this, if I simplify, it is becoming C 100 into 100 into 100 into 10. But what they have given, the new unit of pressure is increased by 1000 times. This is also not true. So here, if you see all the options, option B is the correct option. So either we can verify all the options or we can stop the calculation at the second point only. But how to verify that you need to understand here. Okay. So let us continue the next sum. Suppose we employ a system in which the unit of mass equals 100 kg, the unit of length equals 1 kilometer, and the unit of time is 100 seconds, and call the unit of energy joule. So here it is just written in a reverse order. Okay. So then what is it is given? See, that is, what is the question? Suppose we employ a system in which unit of mass is 100 kg and unit of length is 1 kilometer and the unit of time is 100 second, and the call of energy is taken as, that is 1 joule is equal to 1 e-joule is equal to 10 raised to 4 joules. So here we just need to calculate when the units are changed from the original. So previous one and this one is little bit similar only. That is, as we know that energy is written as m L raised to 2 T raised to minus 2. This is the dimensional formula for energy. Next, so what they have given here for new system, it is given as 1 E this is equal to 100 kg into, so this is 1 kilometer square and here it is 100 second square. So now this is equal to, we can write it as 100 kg into 1 kilometer is 10 raised to 3 meter. This can be written as square it is, therefore it becomes 10 raised to 6 meter square, and here the time is becoming 10 raised to 2, but here to the power of 4 it is, therefore we will take it as 10 raised to so here it is minus, therefore it becomes 10 raised to minus 4, 10 raised to minus 4 per second square. Now this is equal to, it is 10 raised to 4 kg meter square per second square. Means this is equal to what? It is 10 raised to 4 joules. It is 10 raised to 4 joules. Okay. So this is how we can write it. This is how we can write it. Therefore, the correct option is 10 raised to 4. That is option A is the right option here. Option A is the right option. Okay. So let us see the next question. Option A is the right option here. Next question. One gram centimeter per second is equal to x Newton second. Then number of x is equivalent to, number of x is equivalent to. So how to do this one? That is, gram centimeter per second is equal to 10 raised to minus 3 kg into 10 raised to minus 2 meter into per second. So that is gram centimeter per second. To SI system I have written, that is 10 raised to minus 3 kg into 10 raised to minus 2 meter into per second. So this is equal to, it is nothing but what, 10 raised to minus 5 Newton second. It is 10 raised to minus 5 Newton second. Right? That is option D is the correct option here. That is, if 1 gram centimeter per second is equal to x, Newton second, then number of x is equivalent to. So what I have did, so they have given it as gram centimeter per second, that to SI system, because it is given, unit is given in terms of what SI system, that is Newton second. Therefore, take that Newton second, convert it. Okay, so this is simple one, that is option D is the right option here. Let us see the next numerical. From the dimensional consideration, which of the following equation is correct? Which of the following equation is correct according to the dimensional analysis? Here we can use dimensional analysis application. Based on that, we can simplify this, right? The given equation from the dimensional analysis, how to correct this? The given equation is what? That is T is equal to 2 pi again verify all the options. So first let us start with the first one, that is 2 pi root of r cube divided by g into m is equal to 2 pi root of r cube, I'll write as it is, divided by gm can be written as what? Gr square. So this is equal to, you can also write it as 2 pi root of r divided by g. It can be written as 2 pi root of r divided by g. How? This r square will get cancelled. Therefore, you are left with what? R divided by g. So, if you see the first option, it is given as 2 pi under root of r cube divided by gm. If I simplify this, I am getting it as 2 pi root of r by g. This is the correct option. Suppose if I take, that is just I am showing you second option, that is 2 pi root of gm divided by r cube. So here the simplification we can do it as gr square divided by r cube. R square will get cancelled. So it is 2 pi root of g divided by r. We don't have such expression. So if you do C and D also, you are getting the wrong answer only. So the simplification and the correct option is 2 pi root of r cube divided by gm. That is option A is the right option. Option A is the right option here. Okay. Let's see next question. A highly rigid cubical block A of small mass m and side L is fixed rigidly onto another cubical block B of the same dimensions and of low modulus of rigidity eta, such that the lower face of A completely covers the upper face of B. The lower face of B is rigidly held on a horizontal surface. A small force F is applied perpendicular to one side of the faces of A. After the force is withdrawn, block A executes small oscillations, the time period of which is given by. So here they have asked the time period of a cubical block. So see the question here, what they are saying. It is a cubical block A of mass m and its side is L, is fixed rigidly onto another cubical block B. So two cubical blocks are there. So just assume that these are the two cubical blocks which are attached to one another. They are of the same dimension, means mass, length, height, breadth, everything is same here. Okay, and low modulus of rigidity. So modulus of rigidity is given as eta, such that the lower face A is completely covers the upper face of B. The lower face of B is rigidly held on a horizontal surface. A small force F is applied perpendicular to one of the side faces A. After the force is withdrawn, block A executes small oscillations, the time period of which is given by. So here we need to calculate the time period. We can take mass as m, coefficient of rigidity is taken as eta. Okay, the coefficient of rigidity etas The dimensional formula is written as m l raised to minus 1 t raised to minus 2, right? By substituting the values, we can check the accuracy of the given formula, right? That is, so again, we can take here all the options and we can do this, or else here you can see the coefficient of rigidity, it is given as m l raised to minus 1 t raised to minus 2. So if you see the given option, the terms where length terms are in the numerator, that is not valid because in the dimensional formula it is in the denominator, that is L raised to minus 1. Therefore, B and C will get cancelled. Either it is A or D now. So how to calculate from A and D? That is, so we can verify for both. I'll just take it for D. T is equal to, that is time period T is equal to, it is 2 pi m divided by eta into L to the power of 1 by 2, as it is in a square root. Okay, this is equal to m divided by eta's dimensional formula is, it is written m l raised to minus 1 t raised to minus 2, and here it is L because L is also there, to the power of 1 by 2. So m will get cancelled, L minus 1, L plus 1 will get cancelled, t raised to minus 2. So t raised to minus 2, if it goes to the numerator, it becomes t raised to plus 2. T raised to plus 2 raised to 1 by 2 is nothing but what? It is t. It is t. Therefore, the correct option is option D. Option D is the correct option here. 2 pi under root of m divided by eta into L. Okay. So that is the equation for time period of a rigid block of A and B when they are attached and having the same dimensions. Let us see the next question. A small steel ball of radius r is allowed to fall under gravity through a column of a viscous liquid of coefficient of viscosity. A small steel ball of radius r is allowed to fall under gravity through a column of viscous liquid of coefficient of viscosity. Okay, after some time, the velocity of a ball, it attains a constant value known as thermal velocity Vt. And here the terminal velocity, it depends on some of the factors they have given, that is mass of the ball, then coefficient of viscosity eta, then radius r, acceleration due to gravity g. Which of the following relation is dimensionally correct? That is, Vt is equal to, it is terminal velocity. So its dimensional formula is L t raised to minus 1. M is the mass. So mass dimensional formula is taken as m, and acceleration due to gravity is there. So acceleration, it is L t raised to minus 2. Then radius, we will get it as L, right? And coefficient of viscosity, it is eta. So by substituting the dimension of each quantity, we can check the accuracy of the given formula. That is, suppose if I take the first formula, is what? That is Vt is proportional to mg divided by eta into r. So Vt is L t raised to minus 1. So this is equal to mass, it is m, acceleration due to gravity, it is L t raised to minus 2 divided by eta, it is m L raised to minus 1, t raised to minus 1, and L, that is for r. So here what happens, this L will get cancelled, m will get cancelled. you will get it as L t raised to minus 1, L t raised to minus 1. So no need to do other calculation, means with other options, because if we simplify the first one, we can see RHS and LHS are equal here. Therefore, the correct option is option A. Option A is the correct option, right? Let us see the next question. A dimensionally consistent relation for the volume V of a liquid of coefficient of viscosity eta flowing per second through a tube of radius r and length L and having a pressure difference P across its end is. That is, we have a dimensional consistency relation for the volume V of a liquid coefficient of viscosity eta, which is flowing per second through a tube of radius r and its length is L, which is having a pressure difference of P. Okay, so here the pressure is given by the dimensional formula is what? It is m L raised to minus 1 t raised to minus 2, and radius r is equal to, it is L, and coefficient of viscosity is equal to m L raised to minus 1 t raised to minus 1, and for length we will get it as L, right? So again we can take all the options and we can do, but here if we take the first one, that is V is equal to pi P into R raised to 4 divided by 8 eta into L. So substitute the dimension formula. It is volume, that is velocity here. Right. So pi dimensionless quantity. Pressure is given as m L raised to minus 1 t raised to minus 2. Then length radius is L raised to 4 divided by 8 eta. Eta is m L raised to minus 1 t raised to minus 1. L ka L we can write as it is. So we can simplify this. If I simplify this entire term, we will get it as L raised to 3 t raised to minus 1. So here again the RHS is equal to LHS. Therefore, the option A is the right option here. Then the next question is, with the usual notations, the following equation, that is S is equal to U plus half A into bracket 2t minus 1 is. Okay, so S is usual notations in the sense S is distance, U is initial velocity, half A acceleration, T is time minus 1. So here the question, options what they have given, see, only numerically correct, only dimensionally correct. Option C, both numerically and dimensionally correct. Either numerically nor dimensionally correct here. Okay, so what we can do here, we can substitute the dimensional formula for the given equation. So we know already the dimensional formula for all the quantities as it carries the usual meaning, right? So therefore S is equal to what it is, L t raised to minus 1 is equal to velocity is, sorry, it is distance, no? So this will be only ST they have given, that is distance traveled by the body in tth second. Okay, in this second, therefore it becomes L t raised to minus 1. Now you write for u velocity, it is L t raised to minus 1 plus half, nothing is there, therefore L t raised to minus 2, and here it is time, therefore it is t. If I simplify this, this will be no simplification, it is as it is, L t raised to minus 1 plus L t raised to minus 2 into t is written as what? L t raised to minus 1 itself. Therefore, you can see here both it is RHS and is equal to LHS. So therefore, we can say that dimensionally it is correct. And after deriving this equation from kinematics, we can also prove that this equation is correct numerically also. So if we use kinematic equation relation, actually we have that is S is equal to ut plus half at square. But here they have taken it for tth second. Therefore, by using that method also, graphical method also, if you derive numerically also, you are getting the same equation. Therefore, we say that this given equation is both numerically and dimensionally correct it is. Okay, that is option C is the right option. Option C is the right option here. Let's see the next question. If velocity v, acceleration a, and force F are chosen as fundamental quantities, then the dimensional formula of angular momentum in terms of v, a, and F would be. Okay, so here what we need to do, that is angular momentum in terms of v, a, and F, we need to calculate. That is, so substitute the dimensional formula for each option. See here, that is velocity v is equal to, we know that it is L t raised to minus 1. Then next we have acceleration is equal to what? It is L t raised to minus 2. Then next we have force is equal to m L t raised to minus 2. By substituting the dimension of each quantity, we can check the accuracy of the formula. Okay, so angular momentum is equal to, so angular momentum is equal to, we can verify for all the options. So here I'll take the option B, that is F v cube a raised to minus 2. So angular momentum is what? It is m L raised to 2 t raised to minus 1, which is equal to F is m L t raised to minus 2 into volume is L t minus 1 raised to 3, and then next we have it as L t raised to minus 2 raised to minus 2. So this is equal to m L raised to 2 t raised to minus 1. M L raised to 2 t raised to minus 1. Therefore, the correct option is option B is the right option here. Okay, so here we can go for all the substitution, but how it happens when you will be perfect with the dimension concept, no? By seeing the options only you will get a little idea, because as we know that the dimension of what it is, m means angular momentum, it is m L raised to 2 t raised to minus 1. So in the given question, if you take option B, it will fit the given condition, that is RHS is equal to LHS, right? So therefore option B is the right option here. The next question. The largest mass that can be moved by a flowing river depends on velocity, density of river water, and acceleration due to gravity. The correct relation is, see here what they have asked you, the largest mass that can be moved by a flowing river. It depends on velocity, density of water, and acceleration due to gravity. The correct relation we need to calculate. See here. So m is mass having dimension formula m, and velocity is L t raised to minus 1. Then density is taken as m L raised to minus 3. That is mass per unit volume, and acceleration due to gravity is L t raised to minus 2. Okay. So what we can do here, we can take the first equation. So first equation, just I'll show you. That is first equation, if I take it is m is equal to rho square into v square divided by g square, right? This is the first equation. So dimensional formula for this is m is equal to rho square will be m L raised to minus 3 whole square, and v square will be, it is what happens, it is L t raised to minus 1 to the power of 6 divided by L t raised to minus 2 to the power of 2. So here if you simplify this, we are not going to get only m. So dimensionally it is not correct. Similarly, you can substitute for second, you can substitute for third, you can substitute for fourth also. So here I'll take the fourth equation, that is m is equal to rho into nu raised to v raised to 6 divided by g cube. This will be m, and this is equal to m L raised to minus 3, and here it is L t minus 1 raised to 6 divided by, it is L t raised to minus 2 to the power of 3. That is equal to, it is becoming. So if you simplify, so after simplification you are getting it as only m. You are getting it as only m. That is option D is the correct option here. Option D is the correct option, right? Let us see the next question. If P represents radiation pressure, C represents speed of a light, and Q represents radiation energy striking a unit area per second, then non-zero integers x, y, and z such that P raised to x, Q raised to y, C raised to z is dimensionless R. That is given by, so here it is given as P represents radiation pressure, its power is x. C represents speed of light, its power is y. And Q represents, so either we can take it as CQ, PQC also to the power of z. Okay, so this is equal to this per unit area per second and then non-zero integer. So it is becoming P raised to x, Q raised to y, C raised to z is equal to, as it is dimensionless they have mentioned, therefore it will be m raised to 0, L raised to 0, T raised to 0. So by substituting the dimension of each quantity in the given expression, what it is, the dimensional formula for P, it is m L raised to minus 1, T raised to minus 2 to the power of x. Then Q is m T raised to minus 3 to the power of y. Then C, it is L T raised to minus 1 to the power of z. So this is equal to, so simplify for m, it becoming x plus, it is becoming x plus y. L, it is becoming L raised to minus x plus z. Then T, it is becoming minus 2x minus 3y minus z. So this is equal to what it is? This is equal to, it is dimensional less quantity, that is m raised to 0, l raised to 0, t raised to 0. Okay. So now we can equate the powers here. It is becoming x plus y is equal to 0. Therefore, we can write x is equal to minus y. Next, it is becoming minus x plus z is equal to what? 0. Therefore, it is nothing but x is equal to z. Then next, minus 2x minus 3y minus z is equal to 0. So, if I substitute whatever x, y, this from equation 1 and from equation 2 in this equation 3, we will get, so after simplification, we will get it as that is becoming x is equal to 1, y is equal to minus 1, z is equal to plus 1, x equal to 1, y is equal to minus 1, and z is equal to plus 1. That is, you can see the given option, that is option B is the right option. That option B is the right option. Let us see the next and the last question for the today's class. The volume V of water passing through a point of a uniform tube during t seconds is related to the cross-sectional area A of the tube. Velocity u of water by the relation is given by V is equal to, V is proportional to A raised to alpha, U raised to beta, T raised to gamma. Which of the following will be true? See here how to do this. So again, we need to write the dimensions here. That is nothing but is equal to, that is here it is given as volume, therefore that volume is proportional to A raised to alpha, U raised to beta, T raised to gamma. Therefore volume can be written as L raised to 3. Now area can be written as L square to the power of alpha. Then velocity can be written as L T raised to minus 1 to the power of beta. And time I'll take it as T to the power of gamma. Right? So here this implies, as we have LT term, here also I'll take L raised to 3 and T raised to 0, which is equal to, so simplify this equation, this is becoming L raised to 2 alpha plus beta, then T raised to minus beta plus gamma, or we can also take it as, L raised to 2 alpha plus beta, and it is T raised to gamma minus beta. Right? Next. So by comparing on both the sides. So on comparing on both the sides, the power of L and T, we will get it as 2 alpha plus beta is equal to, it is 3. Therefore, we can simplify it as 2 alpha is equal to 3 by beta. Okay, so this I can keep it as equation 1. Then T to the power of, it is gamma minus beta. It is gamma minus beta. So that is equal to what? It is 0. Therefore, it is becoming gamma is equal to beta. So it is becoming gamma is equal to beta. So here if I take as gamma is equal to beta, our equation becomes alpha is equal to 1 divided by 2 into bracket. Sorry, this is in the plus, no? So if it comes this side, it becomes minus beta. So therefore here it becomes 3 minus beta. It becomes 3 minus beta here. Okay. So here if you see, that is alpha is equal to beta we are getting, but sorry, gamma is equal to beta and alpha is equal to, we are getting it as 1 by 2, 3 minus beta. Therefore, what we can say here, as gamma is equal to beta, see the given options. So in option A, we have alpha is equal to beta is equal to gamma. No, it is not at all true. Second, we have alpha is not equal to beta and is equal to gamma. Yes, this is right. Option C, what they have given, alpha is equal to beta. No, it is also not true. Then next we have alpha is not equal to beta, is not equal to gamma also. So therefore, option B is the correct option here. Option B is the correct option in the given question. Right? So this is how we can use the dimensional application and we can simplify the given question. Okay. If velocity v, force and energy E are taken as fundamental units, then dimensional formula of mass will be. So dimensional formula of mass will be, they have asked in the given question. So what we can do here, we can put the given question, that is, it is taken as fundamental unit, the dimensional formula of mass. So mass is depending on V, F and E. So the question we can write it as that is M is equal to V raised to A, then F raised to B and energy E raised to C. We can take it like this. Therefore, mass is equal to, we can write it as L raised to minus 1 to the power of A. Then forces MLT raised to minus 2 to the power of B. Then energy is ML raised to 2 T raised to minus 2 to the power of C. Therefore, equating on both the sides. So, if I equate it on both the sides, I'll get it as B plus C is equal to 1 and A plus B plus 2C is equal to 0 and minus 2A minus 2B minus 2C is equal to 0. So if we simplify the equation, this equation, we will get it as A is equal to minus 2 and B is equal to 0 and C is equal to 1. Okay, so if I substitute A is equal to minus 2 means it becomes V raised to minus 2, then B is equal to 0 means F raised to 0 and E raised to 1, which means that option A is the correct option here. Option A is the correct option. Okay, so in the next class, we'll continue with remaining numericals. Okay, students, thank you.